Hello guys, this is Rydon Academia. Today we'll be looking at equation of a straight line. We want to see how we can get a straight line equation when given 2 points, or when we are given 1 point and a perpendicular line, and also when we are given a point and a parallel line. Okay, so for our first lesson, okay, we'll be looking at how we can get our equation a straight line function when given 2 points. Alright, so before I go further, I want to tell you that previously we just dropped a video on how to determine gradient of a straight line. Okay, and if you've not seen that video, it's very important to watch it. So we are looking at how we can derive straight line function when given 2 points. Now our basic formula for finding a straight line function is m is equal to y minus y1 over x minus x1. Okay, this is our basic function for deriving a straight line equation. Okay, this our m here stands for our gradient. So after we have solved for our gradient, we can use it to determine our equation on our straight line. Okay, so we'll be taking some examples and we'll be solving this together. Okay, now the first example we'll be taking, you see it on your screen. In a particular week, a company used 300 kilograms of nash when 5,000 units of potash were produced. Okay, that's the first week. In another week, 450 kilograms of the same nash was used to produce 6,500 units of potash. Now we are asked to determine the slope or gradient of the line. That's the first part. We are asked to determine the gradient, okay? And then the second part, we are to determine the equation of the line. So we are asked to do two things, and we'll be doing that very quickly. Now we are given that our x is equal to our nash and our y is equal to our unit of potash. Now for our a, we are asked to determine the gradient, right? We are asked to determine the gradient of the line. And I told you the formula for gradient is that our gradient is equal to y2 minus y1 over x2 minus x1, right? This is our formula for finding gradient. Now, let me quickly state that the equation. We are given 2 points. In our point A, which is the first week, we have that 300 kilograms of nash. Now, from our equation, we are given that our x is equal to nash and y is equal to potash. Okay, so we'll be substituting that quickly. Now, for our first week, which is our week A, 300 kilograms of nash. Okay, our nash is 300. Okay, and we're used to produce 5,000 units of potash, which is our y. And in our point B, which is our second week, we have that 450, that is our x, kilograms of nash was used to produce 6,500 units of potash. Okay, 500 units of potash. Alright, so we are asked to determine the gradient. So this is how we determine the gradient. The gradient is what? Like I've written y2 minus y1. This is our y2. Let's label quickly. This is our x2 because of the second. Okay, this is our y1 and this is our x1 because of the first. So let's substitute and get our gradient. M is equal to our y2 is 6,500 minus our y1 is 5,000. Our x2 is 450 and our x1 is 300. So our gradient is equal to, we have 1,500 over 150. So our gradient when dividing will be equal to what? 10. Now this is for our gradient. This is the first part for our gradient. Now the second part asks us to determine the equation of the line, which is our real topic for today. Okay, that's what we are dealing with today. How we can determine the equation of the line. Okay, so we are going to continue from that. We're using this formula to determine that equation. We are asked to determine the straight line function or the equation of the line, which what we're doing today. Now we already have the gradient, which is our m is equal to 10, right? Now we're going to be using this to determine our equation of the line, which is that our m is equal to our y. Now having no number, okay, our y minus y1 over x minus x1. So our m is equal to y minus y1 over x minus x1. Alright, our m here is 10 and our y minus our y1 in our previous work was 5,000. Okay, our x minus our x1 was 300. Okay, and we can say this is over 1. Now we'll be cross multiplying, and because of the formats, if you watch a video on gradient, I gave a format that y is equal to mx plus c. Okay, so that means y will be coming first, then our x will go behind, okay, and our constant. So this cross multiplication, y will come first. 1 times y is y. 1 times that will give us minus 5,000. Okay, is equal to, now 10 times this is 10x. 10 times minus 300 is minus 3,000. Are we together? So now we collect like terms. The constant will go to meet the constant. So y is equal to 10x minus 3,000. Okay, when minus crosses over the equal to, it becomes plus 5,000. Alright, so if we add this up, our y is equal to 10x minus and plus, we have plus 2,000. Now this is our equation of the line. Okay, this is our equation of the line. Y is equal to 10x plus 2,000. And you can see our gradient reflecting as a coefficient of x. Like I said, this is a coefficient of x when y is subject of the formula. So this is the equation of the line. Alright, so we'll be taking another example quick. Alright, for our next question, we have that a is equal to minus 2 and 5. Okay, and our b is equal to minus 3 and 10. And we are asked to determine the equation on the straight line from that. Alright, which is our straight line function. Now, like I said, before we solve for straight line function, first of all, we have to solve for gradient. Alright, so solving for gradient, we have that our m is equal to y2 minus y1 over x2 minus x1. Okay, let's quickly identify x1, y1, x2, and y2. Alright, so let's substitute for this. M, which is our gradient, is equal to y2 is 10 minus y1 is 5. Okay, and our x2 is minus 3 minus, and our y1, our x1, sorry, x1 is minus 2. Okay, x2 minus x1. Now our x1 is also carrying a minus sign. Okay, that's why I'm putting it in the bracket. So minus times minus will give us plus. So we have that our m is equal to 10 minus 5 is 5. Alright, now minus 3 plus, because of these two minus becomes plus, minus 3 plus 2 will give us minus 1. So our gradient is equal to 5 over minus 1, which is equal to minus 5. Alright, so now we have found our gradient. We can now use this to solve for our equation. Now remember, our formula for finding equation of the line is that our gradient is equal to y minus y1 over x minus x1. Okay, so we'll be bringing that up quickly. Our gradient is equal to y minus y1 over x minus x1. Alright, our gradient here is minus 5 is equal to our y minus y1. y1 from here is 5. And our x minus x1 from here is minus 2. Alright, so let's solve. We have minus 5 is equal to y minus 5 over x. Minus minus will become plus x plus 2. And this is also over 1. So we can cross multiply. Remember, our format remains this, that y is equal to mx plus c. This is how to present our equation. Okay, so our y will be coming first. Y times 1 will give us y. Y 5 times minus 5 times 1 will give us minus 5. is equal to minus 5 times x is minus 5x. Minus 5 times plus 2 will give us minus 10. Okay, now we collect like them so that our y is alone, okay, according to our format. So our y is equal to minus 5x minus 10. Now if our minus 5 goes the other way, it becomes plus 5. Alright, so our y is equal to minus 5x minus 10 plus 5 will give us minus 5. Now with this we have gotten our equation. Okay, this is our equation on the straight line when we are given these 2 points. Alright, you can see our gradient, which is the coefficient of our x when our y is subject of the formula, which is minus 5. Our gradient is clearly reflected here. So with this, we've come to the end of this subtopic section, which is deriving our straight line function when given 2 points. The next video I'll be posting how we can derive our straight line function when we are given only 1 point, as well as a parallel line. Alright, as well as a parallel line. So please, if this video was helpful to you, subscribe to this channel, like our videos, and share with others. Thank you.